Is good afternoon one all. It is audible.
Yes, sir.
Yes. For today's class, I request 10 people to join with us till the end. Yes, for today's class 106, 1078, 109, 111, 112, 115, 116, 118, 109. Please join with us. Please unmute your mic and please join with us till the end. Shivani, Raksha, Sri Ranjani, Sanjay Karthik, Satyan, Karthik Raja, Ajit, Udesh Jari, Vimaleshan, and Vinod Khanna. You please unmute your mic and please join with us. Yes, even Purna Chandra, Yash Mohan, Yuvaraja, you can also join with us till the end. You please unmute your mic and please join with us. I think anyone joined?
Good afternoon,
No
sir.
one. I think.
Good afternoon, sir.
Yes, good afternoon. Who's this? Who's this?
Good afternoon, sir.
Yuvraj, sir.
Who's this? Yes, tell me your name.
Yuvraj, sir. Yuvraj.
Yuvraj.
Roll number 120. Yes, sir.
Yes, 123. 123. Yes, very good. Very good. Please, others also please join with us till the end from 107 to 123. Please join with us till the end. And do you have any doubts with the last presentation, that is kinematic arrangements? This is what we have seen in the last class. And see some more addition over the these derivation, that is R and L cos theta and L sin theta. This is what the L cos theta and this is what the L sin. This I have discussed during the presentation itself. And okay, where we stopped, we are solving problems. And okay, please take your calculator and notebook and pen. Today also we will see some problems in robot kinematics, and you please make a note of this particular problem, that is problem 4.3. A vector v is equal to 3i plus 2j plus 7k is rotated by 60 degree about z axis of the reference frame. We need to very conscious, very aware that the z-axis, the 60 degree rotation is about the reference frame, and it is then rotated by 30 degree about the x-axis. It is also from the reference frame. See, it is also from the reference frame. And what we can do, we are usually what we are taking. We are taking this as H, is it right? The rotation transformation matrix, R into X into theta. That is what our rotation transformation matrix. Before that, we'll revisit the three different formulas of the rotation transformation matrix, and we'll see this is the rotation transformation matrix. Assume this is a 4x4 matrix. In that 4x4 matrix, the last, that is fourth row and fourth column, should be 0, apart from the fourth address, that is 4 into 4, that is when 4 is 1. And when we are concerning about x comma theta, r1 should be, that is a11 should be 1. The rest in the first column and first row should be 0. And please remember that we have in main diagonal we have cos theta, and in the secondary diagonal we have sin theta, and that too with the sign in x and concerning about z we have minus at the top sine theta, and in the case of y, we have bottom sine has a negative symbol. You please remember these formulas in order to solve the problems. And during y-axis, the term 2 should be 1, and the rest in that particular row and column should be 0, and we need to rearrange the cos and sine theta. Similarly, in the case of Vz, the third row and third column should be 1, and rest should be 0. Here it is 0. Rest should be 0, and apart from this, the main diagonal should be cos, and the secondary diagonal should be this is the main diagonal. The secondary diagonal should be sine theta, and this is what we need to remember, these rotational transformation matrix. And with these rotational transformation matrix, we'll solve this particular problem. And 60° about z axis and 30° about the x-axis, and both from the reference plane. Find the rotation transformation. That is what we are going to find. That is what we are going to derive with. We are going to find. We are going to identify the new point after rotation. What will be the position of the end effector? That is what we are going to find. And here we are concerned about rotation transformation, and in some cases in the past we were concerned about the translation transformation. And see here, this is the formula. In that formula we were adopted the theta. So 60, here we have adopted 60, and similarly in the x-axis formula we have adopted 30. And this is what the solution in that textbook, that is Groover. And it was there was an issue with the calculation, and they are restricted with one single digit, and that too we have some problem with the solution and all. So therefore, you please make a note of this H1 and H2 first, and please make a please make a note, the H1 is equal to R into H1, and similarly you please make note of H2. And the second rotation is performed here about the reference plane. Hence, the two matrices are reversed during the multiplication. See here, what we are going to do, we are going to multiply with H2 and then H1. Because the reference we are making the inclination with that of the reference plane. Therefore, we can consider the H2 at first and H1 at the next. Concerning the second problem, see here that there is another problem is also available. The 60° about z axis, it was made with the reference frame, and it is then again rotated. It is then again rotated about the x-axis from the rotated frame. In this case, what we need to do, we need to multiply with H1 and then H2. We need to do multiplication, matrix multiplication with H1 and H2. And this is not the case here. The second rotation is performed about the reference plane. Then we can take it as H2 and H1. And please make a note of this H1 and H2. It was noted. Raja, it was noted. Shall we move here? Raja?
Yes, sir. I'm not.
Yes,
Sir.
sir.
Give me one minute.
Yes. Once it is over, please tell me.
Sure, sir.
And please take your calculator and find the values of cos 60, sin 60, cos 30 and sin 30. Keep your mode in degrees. When we are concerning about the radian pi and all, when we are applying with pi, at that time you convert into radian. At present, you keep your mode as degree. Find the value cos 60, sin 60, cos 30 and sin 30, and round it off with 3 digits. What was cos 60? What was sin 60? What was cos 30? and sine 30. I think you note it down. Here see H2 and H1, we calculate the various values of cos 60 and sin 60, cos 30 and similarly cos 30 and sin 30. And what we need to do, we need to write this column at the top of this matrix, that is 0.5, 0.86600. Then we need to multiply with each row, that is 0 into 0.5 plus 0 into 0.866, that will give 0.5. 0 into 0.5 plus 0.866 into 0.866, that will get 0.75. Similarly 0 into 0.5 plus 0.5 into 0.86, that will become 0.433. Similarly, we need to do with this column, second column, third column, similarly fourth column. This is what our result. This is what our result. We now we got the H value. What we need to do? We need to find the newer position, that is u is the newer position. U is equal to h into v. V is a point vector. What was the earlier point? That is 3 to 1 is the earlier point, and 1 is the weight factor. And now to do multiplication with these 4 cross 4, we are introduced to 1. And why we are keeping this last column, that is fourth column, should be 0. Here what we need to do, there won't be any translation, and there won't be any changes in the x direction, y direction, z direction with that of the inclination. When we have certain changes over the x, y, z, at that time we need to adopt with these 3 digits, these 3 provisions. Here we have 0, 0, 0. Then here we need to adopt x variation, y variation, and z variation. That is why we have the fourth column. And here we doesn't have any such translation with the Cartesian, and therefore we have 0, 0, 0 in the fourth column. And by doing multiplication with these matrix, we will get minus 0.232, minus 0.384, and 7.861, and this is what the result. See how the answers are different from Groover. See here the minus 0.1, minus 3.9, 6.22. See how the results are varying. Minus 0.2, instead minus 0.1 we are getting minus 0.232. Instead minus 3.9 we are getting minus 0.384. Instead 6.22 we are getting 7.862. So we have to be very conscious with dealing with the digits, and this is what the results of the above problem. And I think you noted. You please make a note of this particular problem. Example 4.4. A vector v is equal to 3i plus 2j plus 7k is rotated about 60 degree in the z axis with that of reference plane, and then it is rotated 30 degree about the x axis from the rotated frame. Find the rotation transformation, and here the second rotation is about the rotated frame. The multiplication order does not reverse. And you may have some particular doubt. Sir, we can do in the case of matrix multiplication, it is irreversible. But do here H1, H2 may not be changed. Concerning the last problem, it won't make any changes. And here you can find H1, the H1 is equal to H1, H2. And you solve this matrix and tell me. And concerning this particular problem, we have to multiply H1 and then H2. H1, H2 in that order we need to do. and the rotation transformation matrix are z 60 degree. Therefore, we are applying 60 degree with the cos 60 minus sin 60, sin 60, cos 60, and the rest are one with the main diagonal. And instead theta, we are applying 30 in x-axis, and then we need to do multiplication. Yes, you please make note of this h1 h2. I think all of you aware about the matrix multiplication. Do you have any doubts with the matrix multiplication? Do you have any doubts with these matrix multiplication, these basics and all?
No, sir. No.
Others? Do you have any doubts with these matrix multiplication?
No, sir.
No, sir. We are clear with matrix.
Yes. Yes. Okay, where in syllabus where we have robot kinematics, which is concerned about which unit? We are talking about. We are dealing with which unit? At present, we are in which unit? We were in control techniques, that is path control, robot controller operation. We are in the first unit. Robot arm geometry we discussed, and application areas we were introduced. At present, we are dealing with the second half of the first unit. Even we covered the end effectors in the second unit. There were types of end effectors and the arm toolings, arm tooling and all we were already discussed. But at present, we are in the first unit, that is control techniques, path control, and robot control operation. Yes, and by multiplying this point vector with that of h, will get the New Year position. That is minus 5.25, 6.495, and 4.5 and 1. Yes, this was the next problem. Okay, we'll discuss something, and then I will come back to robotics. And yesterday I have requested someone to talk about the rover which was sent by
Yes,
NASA.
sir.
Yes, go ahead with your content.
So Perseverance, it was launched on July 30, sir, and by
Okay.
NASA, and it was landing on February 18th, 2021. While it also has lander and rover, and also its specialty is it will collect the samples of Martian soil, and which will be retained from the next future Mars missions. And also it has a one more helicopter attached. Sorry, it's uh, attached with it, sir. That is called Ingenuity, and so that will be that will be the first helicopter to fly over the Martian atmosphere.
Wait, Jyotsna. 1 minute. Sir, it's
Yes,
echoing for us, sir.
echoing from where?
I don't know, sir.
Sir, you have to mute your mic, sir. Then it won't echo, I guess.
Yes, sir. I think it's from your side, sir. Not sure.
Yes, yes, yes. We'll try. We'll try. Go ahead, Joseph. Go ahead, Joseph.
Yes, sir. It's not echoing now, sir. Yeah. Is this audible, sir?
Yes, go ahead, go ahead, go ahead.
Yes, sir. So, like, yeah, this after this Perseverance was launched, and comparing with Mangalyaan, it's just a orbiter, sir. And it was actually planned to schedule to run only for 6 months, while and currently it's working on seventh year, and whereas that is just an orbiter, and here it's a rover and a lander, and already they have sent Curiosity. So, comparing with this, Ingenuity is also attached to this, so this is new to us, like it will give us lot of information, so that is new about it.
Where we failed while
Yeah,
where
7 minutes terror.
in the case of ISRO, where we failed what point we failed
Chan-
during landing, is it
Mangal
right?
Mangalyaan was, oh, Chandrayaan 2, yes sir. For Chandrayaan 2 we didn't land, so else otherwise, like orbiter is still in progress, but still the lander was having some issue, so didn't because of that sensor issue it didn't land properly. But this Mangalyaan is just an orbiter, so it was successful, sir.
Yes, yes, yes. Okay, very good, very good, very good. Very good, very good.
Thank you.
If time permits, we'll discuss more about these Mangalyaan, Chandrayaan, and the new launch about NASA.
Yes, sir.
And anything more about the current affairs? Please, a quick recap about the current affairs.
Well, the Puducherry government lost its majority.
Ah, yes, yes, yes. Yesterday, the past CM, that is CM, given resignation because they doesn't have the majority, and that is why, due to various political moves that was happened. And I think you are all aware that recently Kiran Bedi relieved from Garner, and Tamilisai Soundarajan taken charge of additional charge of Pondicherry, and subsequently it happened. And concerning the Diksha Ravi, who is an activist, social activist, that too with the what happened for Diksha Ravi?
Sir, she's given bail. Sir. She got into jail because the toolkit case.
Okay.
She was given bail.
Yes, yes. That is what the headlines, today's headlines. Even see, even in the age of 22 years, he's in the headlines of Hindu, and that is what we need to we have conscious, and the age won't be matter. The things which we are doing, that is what matters. That is talks about you. And regarding the ongoing farmers issue and toolkit relating to the ongoing farmers issue, she was arrested, and he got bail yesterday. And yeah, concerning the Tamil Nadu, yesterday Deputy Chief Minister Panniselvam given the budget, and the debt burden to elevate to 5 lakhs crore in 21-22, and that was very unfortunate for Tamil Nadu, being a person in Tamil Nadu, and the debt over the head increases day by day. And when there is a new financial statement and financial reformations and all, we expect when there is a budget, we expect more concerning about the finance. And there are major drawback with that of the newer budget in Tamil Nadu is the debt crossed to 5 lakh crore, and that was unfortunate. And similarly, there are political issues in Nepal, and 5 states the number of person affecting the new COVID virus elevated, and those things when time permits we will talk. Do you want to share anything?
Sir, today at 11:35 a.m., National Stock Exchange closed suddenly. Sir.
Which stock exchange?
National Stock Exchange, India, NSE, Nifty.
Oh, okay. Oh, stopped.
Yeah. They had some glitch in displaying prices stopped, so it completely stopped. Sir.
Oh. Now it resumed. Around
No,
after
sir. Bombay Stock Exchange is going on, but Nifty is not changing.
so till even
Stagnant.
after 1.5 hours it won't resume.
It has not changed till now, sir.
Oh. Yes, it is a big issue. It is a very big issue.
It has resumed, sir.
Resumed.
Yes, sir. 1 p.m. only.
Okay. Good.
So you are not listening up our class?
Yes, Chitta's enquiring. Very good. You are not listening class. You are watching the news channel. Nikhil.
Sir, someone else in my house is watching, so I got to know about it.
No, not about Arun Balachi. I am asking Nikhil.
No,
Okay.
sir, I read it after the break, like 11, around 2, when we have had break. 12, around 12.
Just for fun. No issues. Okay. Okay, you please make a note of this fifth problem. A vector v is equal to I plus 5j plus 3k is rotated by 60° about z axis and translated by 3, 4 and 5 units in x, y and z direction respectively. Find the vector with reference to reference frame. See here I have in the for example 4.3 I revealed about the information that there might be changes in the x direction, y direction. That is what given in this particular problem, and along with that of z rotation we need to find the changes with x and y and z, and we need to find the new position of the end effector. And our hatch we know when we are dealing with z axis the 3 in matrix 3 should be 1, the rest should be 0 in that particular row and column, and we need to keep the main diagonal as cos, and the secondary diagonal should be sine, and instead of theta we are applying 60°, and the last column, that is fourth column, should be 3, 4, 5, and this is what the result. See, this is what the result. Point 5, 0.8 minus 0.86603, 0.866, 0.5, 04, 0015, 0001, 2, 5, 3 and 1, and by multiplying this 2 we'll get minus 0.33, 8.232, 8, 1. Please make a note. This is what the new point vector is. Shall I move further? Shall I move? Hey, gentlemen.
Yes, sir.
Yes. So far we have seen the robot kinematics. Now we will enter into the kinematic equation using homogeneous transformation. And for that we'll introduce some matrix notations and all. And this was the transformation matrix, transformation T. And please make a note that is nx, ny, nz in the first column, 0x, 0y. Sorry, it is not 0, it is O. Ox, Oy, Oz, Ax, Ay, Az. We have N, O, and A. At the last, we have P, Px, Py, Pz, and what might be the N, O, A. I'll introduce. You please make a note. I'll tell you what these terminologies revealing. The T consists of 4 column vectors. These 4 column vectors are that is based which is used to define the position and orientation of the end of the robot manipulator. These 4 vectors is used to define the position and orientation of the end effector. See here, the illustration shows some robotic arm, that is robotic hand or an end effector attached with the robot arm. The vector P represents the position of the end of the arm. Vector P represents the position of the end of the arm with respect to the base, with respect to the base or base frame. The 3 vectors, that is N, O, and A, specify the orientation of the end effector. The A is the vector called approach vector. A is an approach vector which approaching the job or the required component. Therefore, it is called as an approach vector, and it points in the direction of the wrist. The O vector is called the orientation vector. This is orientation vector, orienting. Therefore, it is called as orientation vector. And the orientation of hand from one finger to another finger. And the third vector is N, and it is normal vector, normal to O and this O and A. That is why it is called as a normal vector. Therefore, it is approach vector, orientation vector, and normal vector. Approach vector, orientation vector, and normal vector. That is why we have N, O, A, N, O, A, and P is the vector. Vector P represents the position of the end of the arm with that of the base. Therefore, the 3 vectors from the coordinate frame related to the base frame, that is the N, O, A. Instead we are X, Y, Z, we are going to use as N, O, A. Approach vector, orientation vector, and normal vector. The approach vector, it points the direction of the wrist, specify the orientation of the hand from one finger to another, and it is the N is normal to 1A. And this is what we are going to deal, that is DH convention. Dinavit and Hettenberg convention might be used for understanding the basic kinematics, and from this we'll call it as the Dinavit Hettenberg conventions may be called as DH convention. And DH convention is usually based on 4 different parameters. One is linked length, twist angle, and offset distance. There are some other conventional system is also available, but at first we will start from Dinavit Hettenberg or DH convention. It consisting of 4 parameters to define the relation between one frame to another frame, one frame to the next frame. The parameters or variable or the link which we are going to concern is the link length, twist angle, and the offset distance. I think you are all making the notes. You please make notes of each and everything. The 4 variable affected by the joint link combination the length of the link AN is defined as the distance along the line that is mutually perpendicular to the axis of two adjacent joints. See here, AN distance along the line that is mutually perpendicular. This is what the diagram we need to have visit. Yes. You please draw this particular diagram. You make a line diagram. No issues. The understanding is very essential. Here Zn, Zn minus 1, Zn minus 2. Similarly, here we have theta n plus 1. Here theta n. Here theta n minus 1. Here we don't have mistakenly they were given theta n minus 1. Here the rotation about this particular axis is theta minus 1. Here what we have a n minus 1. Instead a n minus 1 they were given as theta n minus 1. This is what wrong. This is a n minus 1. Here we have a n. Similarly here it is a n minus 1. This is joint n plus 1, joint n minus 1. Link n minus 1. This axis Zn, Z minus 1, Zn minus 2. And similarly we have the rotation about each axis. In Zn we have theta n plus 1. In Zn minus 1 we have theta. In Zn minus 2 we have theta n minus 1. Have you drawn these diagrams? Yes.
One doubt, sir. Why is theta n minus 1 marked like a distance in that figure?
Yes. Little louder. Why?
Theta n and theta n plus 1 are rotations about the axis, right?
Yes.
Why is theta n minus 1 marked like a distance? Like it's between Zn minus 2 and Zn minus 1. Why is it so?
I think at some time you muted your speaker. I think so. This is not. I think so. I said this is mistakenly it was given. That is what
Okay,
I
sir,
said.
okay.
2 times I said. Here a n minus 1. Here a n minus 1. In this particular axis there might be a rotation. That is what theta n minus 1.
Yes, sir, okay.
Anyway, you are my appreciation. Who asked it?
Yuvaraja.
Yuvaraja. Right. You are listening. It is very transparent that you are listening. Many of your friends are what doing? They are simply sleeping or they are simply giving the attendance and they are leaving. Okay. You please make a note of this abbreviation, that is AN, TN, and theta n.
diagram.
Yes. யார் இது ஒரு நிமிஷம் இந்த டயக்ராம் யார் இது
சார் நான் தான் சார்
யார் பாது
சம்ருத்
சம்ருத் Okay, you listen during drawing. Here AN, we have AN. This AN is the distance between these two particular axes. See here, the AN AN is defined as the distance along the line that is mutually perpendicular to the axis of two adjacent joints. Here we have the axis of Zn minus 1. Therefore, we need to make a parallel line to which is parallel to Zn minus 1. Here there is a line, and distance between these two particular lines should be a. Similarly, here naturally these two lines are parallel. That is Zn minus 1, Zn minus 2 are parallel. Therefore, the a n minus 1 is represented instead a n minus 1 they were represented as theta n minus. So here you have a n minus 1. Therefore, an is defined as the distance along the line that is mutually perpendicular to the axis of two adjacent joints. The twist between the axis of the joint in a plane perpendicular to an is angle Tn. The twist we have drawn one particular line which is parallel to Zn minus 1. The inclination with Zn is Tn. In some other words, that is twist between the axis of the joints in the plane perpendicular to An is angle Tn. The distance dn here, the distance between an minus 1 and an is the normal distance between an and an minus 1 is dn. In other words, the distance dn is the distance between the normal an and an minus 1 of the two links. This is sometimes it is referred as joint offset, and in the case of linear joint, it is called as joint variable. This dn is joint variable. In the case of linear joint, it is called as joint variable. And theta n is an angle between the links measured as the angle between the normal an and an. Theta n is the angle between the links measured as an angle between the normal, that is an and an minus 1. Yes. Now please you make a note of this 4 different points. Yes. An, Tn, theta n and dn. An, here we have an. Here the inclination is Tn and theta n. Here the angle between the link measured as the angle between the normal an and an is in the plane normal to the axis of the joint, and dn the normal distance between an and an minus 1. That is perpendicular distance between an and an minus 1. Okay, shall I move further? Therefore, the position and orientation of the joint n is completely defined with respect to joint n minus 1 by the above 4 parameters. We have rotation. Yes. The abbreviation here. What do you want? Which portion shall I keep?
The DNA part.
DA.
Slightly above this, sir. So the 4 abbreviations, sir.
4 abbreviations.
Yes. Thank you, sir.
Yes. Yes, see, this is what an. That is, we have rotation, translation about D2 and translation about A2 and rotation about X2 and T2. This is what the arrangement about this DH convention. And we have rotation Z and theta and translation 0, 0, 0 D, translation A0, 0, rotation XT. Therefore, we have Z and theta. And we were already aware about the rotation of rotational translation, and therefore we need to keep the third row and third column should be 1, and this is what that matrix, and D and translation matrix, and D in Z, and in translation of A we have the 4th column, first row should be A, and similarly rotation XT. Here X and T instead theta we have T, and this was the end result of this multiplication of 4 different matrices. 4 cross 4, 4 different matrices. This is what the result with this result, we are going to find the newer conventions. So you please make a note of this an. An is equal to cos theta minus sin theta cos t, sin theta sin t, a cos theta cos t minus cos theta sin t, a sin theta 0 sin t cos t d 0 0 0 and 1. The description of end of the link with respect to the robot reference frame can be described at the link coordinate frame Tn. That is what we were derived, that is an, a1, a2 and till an. And application, a 3-dimensional 3D of a manipulator. That is, this is what the TRL type. Theta 1 in z direction and theta 2 in here we have theta 2, link 1, link 2, link 3. See here, shall I move further? Have you written this an? Okay, this is what we are going to talk in next class, that is application example, and how we can use this an for finding the newer convention. This is what we are going to see in the subsequent class. Okay, do you have any doubts with today's class? Do you have any doubts? Or do you want to share anything? If you don't have any doubts, we'll wind up our session. We'll meet during Monday, 10:30. Chitas, do you have any classes during Monday? Chitas, you make a communication with KD Singh. KD Singh attending.
What, sir?
KD Singh is in. Today he is absent. Do you have any other representative from the other class? Chitas, you belongs to B or A?
Yes, sir. I'm B. I'm from B.
B. We have any other representatives from A?
I think Shivani, sir.
Shivani, if feasible, you have a conversation with Shivani and is arrange a class during this week, whether it is feasible.
We will discuss and tell you.
Yes, sir.
Is KD Singh? Yes, KD Singh. Yes,
Sir,
you play, have a conversation and tell me.
Am I audible, sir?
Yes. Now we are audible.
Sir, I'm saying that we will discuss and tell you, sir. You have to check for both the classes. That's why.
Yes. You have a conversation and tell me.
Okay, sir.
And the date for our CT is 3rd March. Is it right? And you please make arrangements of the class cancelling with 3rd March as per your timing, your wish. You can have the schedule, but it should not affect our class. Our class during Monday, that is 3rd March, is I think Wednesday. It should not be between 12:30 to 1:20, and rest of the time you can, as per your wish, you can do. But the accordingly you need to do changes over that of the classes in that particular time.
So actually, the thing is that some teachers from Prode are saying that the teachers are only have to make their exams only in their period only.
Oh, okay.
But then also, sir, we will try, if our teacher cancelling the class, then I will talk with Prod BCR and we will try to bring out any 1 hour extra if we are unable to find.
Yes, anyway, we have time. We'll discuss. If feasible, you make arrangements of 1 hour during this week. That is tomorrow and day after tomorrow.
Okay, sir.
You please have a conversation until. Okay, thank you. Thank you. We'll meet during Monday. If class arranged, your representative will disseminate the information.
Okay, sir.